Hi, this is Nimla Rednam. In this video, we are going to discuss the sums from exercise 9.3 from NCERT textbook class 8. In the previous video, we discussed the concept of volume of a solid shape, and in particular, we looked at a cube, cuboid and a cylinder. We looked at a couple of methods to derive the formula for the volume of a cube, cuboid and a cylinder. So let us first solve the solved examples and then we will move on to the exercise. The sums given regarding this particular concept of volume of a solid shape are pretty straightforward, and we will be finishing it very quickly. So let's look at the first example. Find the height of a cuboid whose volume is given as 275 centimeter cube and base area is given as 25 centimeter square. Now here we have already discussed that for standard solid shapes, the volume is nothing but base area into height, right? So in this case, the volume is given as 275 centimeter cube. So we are going to equate this to the base area, which is given as 25 centimeter square into height. So from this you can say that height is nothing but 275 by 25 centimeters. So when you simplify this, you're going to get 11 centimeters. So that is your answer. The height of the cuboid is 11 centimeters, right? Now let's look at the next example. A go down is in the form of a cuboid of measurement 60 by 40 by 30. How many cuboidal boxes can be stored in it if the volume of one box is given? So you know the capacity of the cuboid from its dimensions. So, and also you know the smaller cuboid box volume is given to you. Now what we are going to do is, first we are going to find the volume of the cuboid, right? 60 by 40 by 30 meter cube, right? So this is nothing but 6 4 24, right? And then I want to leave it like this, in fact, because I'm going to have 0.8 in the denominator in the next step, right? So let us say small v, that is the volume of the small cuboid, is given to be 0.8 meter cube, correct? It is given as 0.8 meter cube. Okay. Now, number of boxes, such boxes, into volume of each such box is nothing but my total volume. So I can write the number of such boxes is nothing but this big volume by the small volume, which is 60 into 40 into 30 by 0.8, which is nothing but 8 by 10. So I'm going to write it like this, right? Now this is 5. Now I'm going to simply simplify this. 18 5 is 90, and then I have 3 zeros here, so that is 90,000. So the answer is 90,000, right? And then let's move on to the next example. A rectangular paper of width 14 centimeters is rolled along its width and a cylinder of radius 20 centimeters is formed. Find the volume of the cylinder. Now here the rectangular width, we know that net of a cylinder, you know, the lateral surface, the net is nothing but a rectangular sheet. So you can see the figure, it's very clearly given how this rectangular sheet is transformed into a cylinder, right? Now here the width is nothing but the height of the cylinder. Okay. Now we are asked to find the volume of the cylinder. In order to find the volume, I need the radius and the height. So the radius they are saying is nothing but 20 centimeters. And what is the height of the cylinder? It is nothing but width of the rectangular paper. So here this phrase here, it's very important that you understand this phrase. Rectangular paper is rolled along its width. So this height is going to be retained. This particular 14 centimeters width is going to, it's not going to change. For the cylinder also, it's going to remain as 14 centimeters. That is the meaning of along its width, rolling along its width. Now that I have R and H, the volume is pretty straightforward. Let us look at that. So I have volume is pi R square H, right, which is nothing but 22 by 7. R, it is given to us, so I'm going to write directly. And H, we have come to an understanding that H is nothing but width of the rectangle, which is 14, and the units are centimeter cube, right? So now I have 22 into, this is 44, 88, 88 into 2 is 176, and then I have 2 zeros, centimeter cube. So this is nothing but the volume of the cylinder. Next question. A rectangular piece of paper 11 by 4 is folded without overlapping to make a cylinder of height 4 centimeters. So here they are saying that 11 by 4 is folded along this 4 centimeters. Therefore, the height is 4 centimeters. Find the volume of the cylinder. Now here, the radius of the cylinder is not handed to us directly. We have to find it from the given information and then we can proceed. So let us write down the given information. First, they're saying that height is 4 centimeters. Now, in order to find volume, I need the radius as well. But what do we know about the radius? Now, this is my rectangle, which is 11 by 4, and I have a cylinder, which is, is formed as a result of rolling it. Now, this 11 is nothing but the circumference of the base, right? So, I can write 2 pi r is equal to 11 centimeters. From this, I am going to find r. R is equal to 11 into 7 by 22 into 1 by 2. Pi is 22 by 7. So, I am taking those to the other side. The units are centimeters. I am not going to simplify this right now because I am interested in the volume. Right? If they ask me radius, I have to simplify and give a final answer. But since they are asking volume, let me leave it like that. The volume is pi r square h, right? So 22 by 7 into r square is nothing but, this part can be simplified, right? 7 by 4. I'm going to write r square as 7 by 4 into 7 by 4. And then I have h as 4 and the units are centimeter cube, right? So I have 11 by 2 into 7, that is 77 by 2. When I simplify 77 by 2, I'm going to get 38.5 centimeter cube. So that is the volume of the resulting cylinder. You can see they have got the same answer, right? So let's move on to the exercise. First question, given a cylindrical tank, in which situation will you find surface area and in which situation will you find volume? Now here, to find how much it can hold, that is a definition, that is a very definition of capacity, which is the volume. So for the first question, you're going to say volume. Number of cement bags required to plaster it. Now when you're doing plastering for a tank, you are going to plaster the surface. So here it's going to be the surface area. To find the number of smaller tanks that can be filled. Now again, this is regarding capacity, how many tanks you can fill from the given larger tank. So this is going to be volume. So we have in the exercise, first question, it's volume, surface area and volume, right? Let's move on to the second question. Diameter of cylinder A is 7 centimeters, height is 14 centimeters. Diameter of cylinder B is 14 centimeters and height is 7 centimeters. Without doing any calculations, can you suggest whose volume is greater? So what would your guess be? Now here, I want you to look at it. Keep in mind the formula of the volume of a cylinder. The formula is pi r square h, right? Now here, r the exponent or r is appearing 2 times compared to h. So if r is greater, there are more chances that the volume is greater for that cylinder. So if you look at these two figures, r is greater for the second cylinder. The radius is, half of 14, which is 7, whereas for the first cylinder it is only 7 by 2. So clearly cylinder B is going to have more volume. Now verify it by finding the volume. Now actually do the calculation and verify. Let's do that. So for cylinder A, I have pi r square 7 by 2 into 7 by 2 into 7, right? Whereas for cylinder B, it is going to be 7 into 7 into 7. The units are centimeter cube here, right? So I'm going to have 11, correct? And then, so here it is 14. The height over here is 14. So I have 11 into 14, 11 into 49, correct? So, which is nothing but 539. So that is my volume for cylinder A. Let us look at cylinder B. I am going to have 49 into 22, which is double of this actually, which is going to be 871,078. The units are centimeter cube, right? So even by calculation, you can see that cylinder B clearly is having more volume. In fact, it's double of cylinder. Now next question, verify it by finding, okay, check whether the cylinder with greater volume also has greater surface area. They want us to check. So before checking, can you think, if a solid shape has more volume, does it always imply that it has more surface area? So one way to think of it is, again, you have to start from the formulae and then try to compare. So let us look at this particular case that they have given to us. Now here cylinder A has radius 7 by 2 and height 14, whereas cylinder B has radius 7 and height 7, right? Now here if you notice, when I have to find the surface area, and I'm talking about lateral surface area, the formula is 2 pi RH, right? And over here for the cylinder A, 7 by 2 and 7 is the combination. For cylinder B, right? Sorry, I keep taking it as 7, it's 14. 7 by 2 and 14 is the combination. For cylinder B, it is going to be 7 and 7. So you can see that the product RH, the product is the same for the lateral surface area. So you will find that the lateral surface area for this is the same as lateral surface area for the second cylinder, right? That is if you're considering the lateral surface area. When it comes to total surface area, because here R is much lesser compared, half of what you have here, and total surface area includes 2 pi r square. Clearly, you're going to have more surface area for cylinder B. So let us do the calculations and verify that. So I'm talking about lateral surface area first. Okay, pi 2 pi r h, right? So we're going to get 22 into 14, which is nothing but 308, right? And here again you're going to clearly get the same value. 2 pi r h, right? 22 into 14, so it's going to be the same, 308 square centimeters. Now let's look at the total surface area. You simply have to add 2 pi r square to this, right? So what is 2 pi r square here? 2 into 22 by 7 into, your r is 7 by 2, right? So you will see that you have 77 here that gets added. Whereas in the second case, 2 pi r square, I have 7 into 7, right? So here I have another 308. So this is actually 616, whereas this is only merely 385. So you can see that the second cylinder B, has more surface area when you're talking about total surface area, right? So next question, find the height of a cuboid whose base area is 180 square centimeters and volume is 900 centimeter cube. So we know what to do when we have base area given to us and volume given to us. How do you find the height, right? So height is nothing but volume by base area, right? Which is nothing but 5 centimeters. That's the answer for the question. Next question, a cuboid is of dimension 60 by 54 by 30. How many small cubes with side 6 centimeters can be placed in the given cuboid? Now here I have to first find volume of the cuboid and volume of each of these small cubes, and then you divide these two, you are going to get your answer. So first, volume of the cuboid is nothing but 60 by 54 by 30 is the dimensions, right? So I'm going to leave it like this. We'll do the further calculation later on. Units is centimeter cube. What is volume of a cube? It is a cube. So 6 into 6 into 6 centimeter cube. So how many such cubes can fit in this cuboid, right? So here I have right. Now you can simplify this. 5s, 10s, 9s, right? So the answer is 450. Here the numbers given to you, they have very conveniently given the numbers so that this, if you were to really have this practical experiment, you will be able to actually fit in 450 cubes of dimension 6 centimeters in this larger cuboid. However, there is another angle to it regarding the factors. That is, if the dimensions are such that one of the dimensions is not having any factor, um, um, when you look at the it's not having any factor which is matching with the dimension of the cube, then practically it will not be possible to fit in those cubes, although theoretically you might find a integer solution to it. That's one interesting point to note, but you won't have to bother about that for from the exam point of view, because they have made sure that they have given very convenient numbers. Next question, find the height of the cylinder whose volume is 1.54 meter cube and diameter of the base is 140 centimeters. So we are talking about a cylinder here, right? And they're saying that we know that volume is pi r square h, right? And they have given the volume as 1.54 meter cube, okay? And they have given the other dimensions in centimeters. They're saying that the diameter of the base is 140 centimeters. So I can directly write radius as 70 centimeters. Correct? Now they want us to find height. So I'm going to write it as 1.54, which is, you know, I'll have 100 here, and then I'm converting this uh, um, by having 1 meter is 100 centimeters. So I'm going to have so many zeros, right? And then I have pi is 22 by 7, and I have r square, which is 70 into 70. Okay. So on simplifying this, we are going to have cancel these terms. So 22 into 7 is 154. So this gets cancelled. So I have 100, and the units here are centimeters, which is nothing but 1 meter. So the answer is height is 1 meter. Next question. A milk tank is in the form of cylinder whose radius is 1.5 meters and length is 7 meters. Find the quantity of milk in liters that can be stored in the tank. Now here they are asking liters, and we already know the conversion from ml to cc, liters to meter cube, so on. So first let's find the volume in meter cube, and then we will do the conversion. So here we have volume is, because it's a cylinder, it is going to be pi r square h. R is given as 1.5 and h is 7, right? So this is nothing but 225 into 22. I have 49.50 meter cube. Now the conversion part. So like I told you, always remember 1 ml is equal to 1 centimeter cube. Everything else will follow. So now I have meter cube, right? So I have 1 by 10 power 6 meter cube, right? Because 1 centimeter is 1 by 100 meters, right? So 1 meter cube is 10 power 6 ml, which is nothing but 1000 liters. Okay. So if you remember this, every other conversion regarding capacities is going to be straightforward. So now here if I multiply with 1000, I have 49,500 liters. That is your final answer. Next question, the last question. If each edge of a cube is doubled, how many times will its surface area increase? Now, we should always look at the formula in order to answer these questions, because you cannot kind of always get an accurate answer from intuition. So how many times will its surface area increase? So you know that surface area of a cube is 6a square, right? So if I am going to double the side, that's what they're saying, each edge is doubled. So the new surface area is going to be 4 times of 6a square, right? So the answer is 4. Next they're asking, how many times will its volume increase? Now volume is simply a cube. So this becomes 2a cube, which is 8a cube. So how many times has it increased? 8 times, right? So there's one more question, sorry, that was not the last question. 8th question, this is the last question. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. If the volume of the reservoir is 108 meter cube, find the number of hours it will take to fill the reservoir, right? So here what we are going to do is, first we are going to find the we've already been given the volume of the reservoir, right? We are going to convert this into liters. Okay, the meter cube volume we are going to convert to liters, and then right, so volume is 108 meter cube, which is 108 into 1000 liters. We just looked at the conversion. 1 ml is equal to 1 centimeter cube cc, right? So which is 1 by 10 power 6 meter cube, right? So 1 meter cube is simply 10 power 6 ml, or I can say 1000 liters. You can memorize it, but I always remember only one of them without any confusion, and rest everything will follow, right? So this is the volume of the tank. Now the rate is 60 liters per minute, right? So number of minutes it is going to take is into 1000 by 60. Now these are liters, so I don't have any problem dividing them. And here I have 1800 minutes, right? So because they are asking us hours, I have to divide it by 60 and I'll get the answer as 30 hours. So that is the final answer. So with this, we finish this topic mensuration, and in the next video, we are going to start exponents and powers.